Okay, so you guys are smart kids. If I draw this triangle, sim, salabim, and I label it A, B, C, and I ask you, of those three sides of that triangle, we have only reviewed or seen for the first time a trig ratio that deals with only two of those sides. Yes?
Yes.
Excellent. Those two sides are the legs. You guys are smart kids. If this leg doubles in size and this leg doubles in size, what will happen to the hypotenuse? It will also double in size, yes? Which means the hypotenuse is held hostage by ratios, just like the legs are held hostage by ratios. Do you understand what I am saying? So, since there is a ratio that includes only the legs, there must indeed be a ratio that includes the hypotenuse. But there is a problem, because if I put theta there, then I have an opposite, an adjacent, and a hypotenuse, yes? But if I put theta there, what happens? I have a new opposite, a new adjacent, and a new hypotenuse. Not a new hypotenuse, the same hypotenuse. Thank you, Leighton. And if theta is there, well, there must be a ratio that deals with opposite. That leaves this poor guy out all by himself. And we like to be inclusionary in math class. So, there are two more ratios. All of you know what they are, except a couple of you, but you are about to find out. The first one is the sine ratio. The sine ratio is represented on your calculator by the button labeled sin. I get in trouble when I say that. Somebody always gets mad at me, but the letters are S-I-N. When you sound it out, it makes the word sin. It is not sin. It is short for sine, because calculator buttons are small. They do not want to cram extra letters on there. The sine ratio compares, and I'm going to write this in red. Everything I do today with sine will be in red to help accentuate the importance of that. The sine ratio compares the opposite to the hypotenuse. Now, the opposite depends on what? Yes, it depends on theta. Where your theta is. Theta is one of the acute angles. Now, I'm going to over here put one little star. That one little star means what I'm about to write is important. The op, and I'm just writing op because I'm lazy. The op side is across from theta. Please highlight to remind yourself or underline the word across. You all already know that. The second one is cosine. It is shortened on your calculator to cos. The button COS. You're smart kids. Tan is opposite and adjacent. Sine is opposite and hypotenuse. What must cos be? Adjacent and hypotenuse. And again, it depends on theta. And now I am going to put 3 stars because everybody defines adjacent the same way. What does it mean in the triangle to be adjacent? Fudge-sicle. Lauren.
It means that it's like there's the angle that there's theta.
Theta.
The theta will always be connected to the hypotenuse, and the adjacent is the one that's not the hypotenuse.
Excellently done. adjacent is the side attached to theta, but not the hypotenuse. And the reason I have to put that in there is because some kids always say, oh no, which is adjacent? You said it's beside. Theta's here. It's got 2 beside it. Nobody gets to have 2 names. Everybody only gets 1 name. This guy gets hypotenuse. These guys have to share opposite and adjacent. Pardon? Everybody good? All right. Now, that sets up this fake word, which reminds you how to do this. Sine works with opposite and hypotenuse. So if you are using a triangle and you are dealing with the opposite side and the hypotenuse, you are going to use the sine ratio. Cosine is adjacent and hypotenuse. And tangent is opposite and adjacent. Now I want you guys to be aware of something. These are ratios, which means they are always a fraction. This should all be black. A fraction or the fractions decimal. Do you understand what I mean? Don't write this down. Is that a ratio?
Yes.
Excellent. Is that a fraction?
Yes.
Excellent. Is it a decimal? Excellent. How would you find that as a decimal? 2 divided by 3. Excellent. We are all on the same page, which is 0.66 repeating. Yes? Now, what is it a ratio of? Here is what I mean. When you first learned ratios in grade 3, what is the ratio that every teacher made you do? The first ratio you learned in class. It was always the same one. Every grade 3 teacher uses this one. Boys to girls. Or girls to boys in the class. Right? No. What was it's always that one.
Well, usually.
They won't do that one anymore.
Because
But that's beside the point. Everybody knows that, yes? Yes?
Yes.
So what then is this a ratio of? Is that 2/3? Okay, so now tell me what is a fraction? If a fraction is a ratio, tell me why. Barn. No. It's 2 pieces compared to the whole 3 that are available to me. Yes? Okay. Now, is this a pizza?
Yes.
Could be. Is it a bike wheel? Is it a frisbee?
Perhaps.
Is it the Mercedes symbol?
Maybe.
Is it a really poorly drawn peace sign?
Perhaps.
Is it the symbol for phosphorus? It actually is. So the question I ask you is, does this by itself measure anything? No. Or does it measure everything? Does everybody understand what I'm saying? A ratio by itself has no units. Okay? You're going to need to remember that when we get to the work today. I would like to see if that sticks in your head. Now, back to where we were. Here. Oops. Didn't want to do that. Everybody draw this triangle. And please, it is important, I am asking you to draw it the way I am drawing it. It needn't be the same. Just make sure your 90-degree is up here. Aight? Then label the triangle. A, B, C. And then label the triangle's sides properly. What's this one? Lil C. What's this one? Lil A. What's this one? Lil B. Now tell me the sine of A, the cos of A, and the tan of A. When you've done that, tell me the sine of B, the cos of B, and the tan of B. Are these going to be ratios? Are they going to have numbers in them? No, because you have not been furnished with numbers. So you're going to write them as a ratio. What is the sine of A? A over C. What is the sine of B? B over C. What is the cos of A? B over C. What is the cos of B? A over C. What is the tan of A? A over B. And what is the tan of B? All of you should notice a few patterns there, yes? What happened to the sine of A and the cos of B? They're the same. What happened to the sine of B and the cos of A? They're the same. And the tangents are reciprocals. Yes? Excellent. Now, does this AC mean anything to us right now? Does it? No, of course not. Why? Why does this only help us from a purely mathematical standpoint? Byron. Absolutely. Could you build this triangle for me? If I asked you to go draw this triangle, could you? No. Of course not, because there's no numbers, right? Excellent. Now, if I put numbers in 3, 4, 5, could you then fill these in? Great. What would sine of A be? 3 over 5, which would mean cos of B would be 3 over 5, yes? What would sine of B be? 4 over 5, which would make cos of A 4 over 5. And the tans are 3 over 4 and 4 over 3. Now, what is that? A value or a ratio? Those are ratios. Does it matter how big this triangle gets? No. If this was 4.5, then this would be 6, and this would be 7.5. Would these values change? No. The numbers would change, but the values would not. Would the angles that they represent change? No. The angles do not change. Only the ratios change. Do the ratios give us anything except the decimal value of these sides divided by each other? No, they give us no angle, they give us no distances. They give us the context with which to find angles and distances. Does everybody understand? They are nothing by themselves. The sine of angle A in this case is 3/5, which means this angle, it has a value, but that is not it. Cool? Okay. Let's do 3 questions and I'm going to shut up. Remember, all of you, the majority of you have done trig already. Some of you haven't. Let's make sure we can do this. Do I have a theta? What is it? 12. Now, if theta is 12, that means this is the angle from which I am viewing the triangle, which means this is where I decide on my ops, my adjacents, and my hypotenuses. Yes? So if that is the case, what side of this triangle, with which sides of this triangle am I dealing? I am dealing with the opposite and the hypotenuse, which means I am dealing with x and 25. Which of my 3 choices uses opposite and hypotenuse? Sine. Sine of theta equals O over H. I'm writing this because I am teaching right now. Would I ever write that in my own work? No, of course not. But I would write the next thing. Sine 12 equals x over 25. I have done so much algebra. Would I ever write the next step in my own work? No, but we're teaching, so I'm going to. And I want you to understand what it is I am doing. Because, and you'll see why in a second, how do I get rid of divided by 25? Multiply by 25, multiply by 25. So x equals 25 times sine 12, yes? Because sine 12 is just a decimal. Does everybody understand what I mean? What I mean by what I just said is if I were to take and draw the angle of 12 degrees and I were to make it a triangle, this value and this value divided would get me sine 12, no matter the size of that triangle. So sine 12 is just another number, like pi. Everybody cool? So now, can I tell you how to solve this? Can I tell you exactly what to do right now, like Simon says? Yes or no? No, why not? Because you all have different calculators, which is why I made you write down how to solve these when we were doing tangent. The only difference is, am I going to be pushing the tan button here? No, what button am I going to be pushing? The sin button. So, however your calculator works, I know on my calculator, all I have to do is push 25 sin 1, 2 bracket equals. Many of your calculators have a different keying sequence. Learn it. Then When you think you have an answer, you can volunteer it to me the way that we have been volunteering answers since kindergarten. Well, I lied. The way you guys have been volunteering answers in kindergarten is just to yell it out. And the teacher, when I was in kindergarten, used to ignore all the yeller-outers, and they would get in trouble and have to stay in at recess. Doesn't happen anymore, because that, of course, excludes them from recess. Byron? It is absolutely 5.2. Is there anyone in the room that could not make their machine get them 5.2? You must tell me now and put your moment of embarrassment aside. Anyone that cannot make their calculator do this. Awesome. Let's go to the next one. Do I have a theta? What is it? 19. Which means this is the spot from which I decide my O, H, and A. Correct? So from that spot, what do I have? I have an A of what value? 40. And I have what else? And a hypotenuse of X. What uses A and H? Cosine. Cos of 19 equals 40 over X. What math do I do here? 40 over cos 19 will equal X. So X will equal what? Please try it. Now, once again, theory. Cos 19 is just a decimal, yes? It is whatever the numbers would be in this scenario. 19 degrees, X over Y. Okay? It's just another number. Your calculator has all those numbers programmed into it. What's the answer? 42.3 is absolutely correct. While we are waiting for my computer to unfreeze, set up the third one. What uses A and H? Cosine of theta is 13 over 22. I don't know the angle, so what do? Shift cos 13 over 22, and I get an angle of 54 degrees. Exactly? Mr. Myers asked questioningly. Of course not. It's 53.87, blah, 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 blah. But we don't measure angles in decimals because they are not dollars and cents. We measure angles in minutes and seconds, like time. So we cannot use decimals for it. Everybody good? I cannot stress this enough. This is the angle. This is the cosine of 54 degrees. This is the ratio. The ratio can give you the angle. The angle cannot give you the ratio unless you know some of the distances involved. Does everybody understand? Okay, here is your job. You are going to do the next 2 pages of work. In your books, that is 60 and 61. 60 and 61. Tomorrow, you will be doing a real life project. In class, it will not take long. But listen to me and listen to me good. You will be allowed to leave the classroom. I know that I will get no reports from the rest of the school because they are going to be emailed to be told that 3 of Mr. Myers' classes, blocks B, C, and D, are all going to be wandering about the school performing mathematical observations. If I get one questioning look from a teacher on Tuesday afternoon after school or Wednesday, I'm going to be thoroughly unhappy. Do I make myself clear? Lovely. Yeah?
Would yours be page 60 and 65 of our workbook, or?
Yes, I was just going to explain that. Yeah. Oh, gimme. What has happened here? Oh, this is the unit that's off. No, you guys are doing 57 and 58. My fault. 57 to 58, which goes with the outline, I think, of 95 and 101, which is the name of those pages. Sorry, guys. Thank you for reminding me that your numbers are out. Everybody, please look on your page 58. I don't know if the photocopying worked very well for you. This angle right here is 58.5 degrees, not percent, degrees. Okay. Tomorrow you will do that project. You will do a slight bit more practice, and then you will have a quiz coming up. Actually, I don't know if I am going to give you guys that quiz. I think I might have decided you guys were smart enough to not need that first quiz. Just let me check. Yeah, I'm not giving you guys a quiz on SOHCAHTOA. Not yet. I'm going to give you guys a quiz on SOHCAHTOA in quite some time. After about page 72 of your book will be your first quiz on trig.
Are we taking our cumulative before the measurement?
Not till we finish our trig unit. Cumulatives are after every 2 units. Yes. Everybody good? So today is this. You check the answers on the bottom of the page. Tomorrow is, I think, I'm actually concerned I got my grade 9s last year to do what I wanted everyone to do tomorrow. So I'm a little bit worried if I did just stuff. I like to fidget. How can you not know that? No, I shouldn't. Because unlike you guys, I can continue to have an intelligent conversation and teach the whole class while I am fidgeting. When you guys get a fidget spinner, what's 7 minus minus 4?
Oh, 11.
Yeah. See, you weren't even fidgeting with anything. It took you that long.
If the 2 minus and 7.
Yeah, I know those 2 minuses. They mess you up.
If you had said minus negative 4, then
Yeah. Okay. If I have already done tomorrow's project with half of this class, then please consider yourselves guides to the half of the class that I did not teach last year. Again, I will spell. It is not, of course. Never mind. Go.